Hi guys, this is a quick video to show how NFTs are implemented on the Dynamo Coin mainnet blockchain. So the NFT system consists of an NFT-aware full node, and that is basically just our full node software, but running with a couple of special switches in the configuration file that tell it to store and relay NFTs. There are three types of NFT nodes, as shown in this diagram. There's a full awareness with database, and those transmit both the blockchain and NFT assets. And then there's an NFT node that does not have the database shown on the bottom here, so it does relay assets, but it does not store them on the disk. And then there's nodes that are unaware of NFTs entirely, and they just transmit the blockchain and have no idea about it. Off to the side, you'll see that we have a web server extension that can interface with an NFT database, and we'll be creating another video to show some of the features of that. But basically what this allows you to do is mine NFTs into the chain, which are web pages. And so this becomes a distributed web server system where a person can point their browser to this web server extension and access NFTs as web pages. So there's a naming system and a series of JSON type configurations that you have to enable to make this all work. But this is the first step in creating a distributed web server, decentralized. All right. On the next slide here, I have the list of assets, the list of workflows. So there's three types of two types of assets, and then three functions. So there's creating an asset class, and an asset class is like a container for assets. So this is your overarching class that you put the assets into. And you can see the steps are here. There's some technical implementations, but basically you need to know that you need to create an asset class before you can create an asset. And then an asset is an individual item within an asset class. Each asset has its own metadata and its own optional binary data. So if you want to store an image or a music file, or in some cases a web page, or really anything, just it's arbitrary binary data, that's what gets stored in an asset. Each asset is unique by its serial number, so you can't create two number twos within the same asset class. And the metadata can be up to 64K bytes of text, and the binary size is up to 16 megabytes. And all of this information is stored in the NFT databases on the NFT-aware full nodes. Then you can take one of those asset classes or assets and change owners. So if you own an asset class or you own an asset, you can send it to a new owner. And note that if you send an asset class to a new owner, the underlying assets do not change owners. So you can maintain control of it, but allow somebody else to take over the asset class if you want to. And then there's a link to the GitHub repository that shows sample implementations of all of these steps, as well as retrieving assets. That code is written in C#, but it basically shows you a proof of concept on how to do all these things on the mainnet chain. To set up a full node that is NFT aware, you simply download the full node software. There will be binaries posted shortly that are NFT aware and NFT unaware, so that people can choose what type of software they want to run. As of right now, July 30th, 2021, I do not recommend running the NFT aware software for any production purposes. It's still a bit experimental. So if you're going to do mining or anything relating to things like exchanges or anything where there's a significant amount of coins at stake, I would not run the NFT aware system just yet. Once we have a few months of stable usage, then we can probably call this production ready, but right now it's very experimental. So there's 3 different kinds, as I said. Non-NFT aware. This is for production usage. It uses less bandwidth and does not use any additional storage. So this is just the regular old version of the Dynamo full node. You can run an NFT aware node, but without the database. And this is simply taking the NFT aware version and then setting the NFT node switch to false. And so just it won't create the database. It'll relay NFTs, but it will not store them anywhere. And then the full version of the NFT, which is required for the web extension, is an NFT aware version with the database. And this is simply downloading the NFT aware version and then setting the NFT node switch to true. Note that if you set the NFT node switch to true in the Dynamo conf file, you must specify an NFT database key string. This is used for symmetric encryption. We're using AES-256. So all of the asset binary data is encrypted. There's no reason that it to be encrypted because obviously it's all public information, but this will be part of the system that allows proof of storage rewards. So there's a need to for you to be able to prove that you can unlock this from your own database, and so that's why we're using the encryption here. The NFT implementation, as you can see from here, is not a hard fork. So if you don't want to do anything with NFTs, you don't have to. You don't have to relay them, store them, upgrade your software at all. It is completely optional. Okay, next slide. So there are some steps to creating NFT asset classes and assets. At the end of this slides, I have a brief video that will show command line examples of these running as well. The current version is in C#.NET Core, so it is completely cross-platform. I've pre-compiled the binary for Windows 10 64-bit, but you can definitely run it on Ubuntu or Mac, a plethora of other .NET Core platforms. The requirement for running the NFT loader program is that you create a settings.txt file, which is in the same directory as the executable. It's a JSON file with the 3 parameters there, which identify the RPC server that you're going to be hitting up against. So you will need to run an NFT aware with database server in order to create your own asset classes and assets or do anything with the Dyn NFT loader program. It will contact your full node, and the full node must have a wallet loaded, and the wallet must have at least 10,000 atoms, which is 0.0001. The reason is that the send to address calls that are made in order to mine the hashes onto the blockchain, which represent the NFTs, all call with a value of this 0.0001. And that number is significant because it is the default minimum relay fee, so that you're guaranteed pretty much to get your transactions passed around to as many nodes as possible so that it gets mined quickly. If we do see fee increases or the mining software starts to selectively only include certain transactions, we may need to increase this or make a different parameter. But that's not the cost of mining the NFT. That's just a token that's returned, or amount that is returned back to you when this RPC call is executed, less any gas fee. So the gas fee right now is about 150 atoms or something like that, and again, that could change as usage grows and perhaps the miners, start to prioritize transactions that have higher gas fees. But right now, it's about 150 atoms to mine something. So you will get the 0.0008 something back from this transaction. It's not going to cost you 10,000 atoms every time you mine something. You must use a wallet that has a receive address. So that receive address must be in the wallet. That's the address that's going to be used to be the owner of the assets. So you have to control it. You can't create assets on someone else's behalf. Everything has to be signed with your private key so that the ownership is guaranteed. And just note that existing nodes cannot be upgraded. You have to start an NFT aware database full node from the Genesis block. So you're going to have to re-download the whole block if you're running an existing node and now you want to support NFTs. So here is the command quick reference. This just shows the loader program and the various parameters and what it does and what they return. It's pretty basic. Some notes below, we've already said the max metadata length is 64K. The max serial number is a 64-bit unsigned integer. The binary data maximum size is about 16 megabytes. The serial number must be between 0 and whatever the maximum number is for the asset class. So if you have a maximum of 100, you can't create 101. You must be the owner of an asset class when you create an asset in that asset class. Obviously, there's a consensus check, so you won't be able to commit that transaction if you do try to do that. All right, and so here's just some examples from the command reference above of different commands. This talks a little bit about the technical design. The gist of NFTs, I'll just do a high level, is that you mine only the hash. So it's only about 30-something bytes that gets mined onto the blockchain. And then all the NFT data is passed around peer-to-peer, just like the other blocks and block header and stuff like that. But it's stored in that SQLite database. And the guarantee that it is immutable is in the hashing. So if you don't trust that a particular asset that's been given to you is the actual thing, you can independently verify that by looking at the hash that was mined on the chain, comparing it to the data that you got, so that if somebody wants to do monkey business with their database, you won't be fooled into accepting an image that's not an image or a web page that's not a web page, those kinds of things. This goes into some of the technical details of the send to address. So the send to address RPC in Bitcoin Core has been modified to include a new parameter called NFT data. If you look at the C# code, you'll see where that call is happening. That parameter is optional. So if there's not a breaking change, and there is a command that's passed to it that says to create assets or send assets, and that's what triggers the initial process of creating or sending an NFT. This is a little detail about how the hash for an NFT is calculated. Basically, it's layers of hashes that guarantee that the data and the owner and everything is unique and provable. And you'll see this code in the C# as well. The demonstration code shows these hashes being created in order. And if any of these hashes don't work out on the server, consensus will reject the NFT data for relay. So nodes which pass bogus NFT data around will eventually be pruned from the network because they're sending bad blocks, and the full nodes keep track of who sends bad data and that kind of stuff. At the very bottom is the serialization format for the asset classes and assets. Note that the binary data is omitted from the asset class. There is no binary data. But all the other fields are the same between the assets and asset classes. And when you do a get against the NFT database, this is the data that's returned in hex format, but you'll be able to decode that data into these blocks in order to retrieve the original NFT metadata and binary data. All right, I'm going to go into a brief video showing sample code actually running with the DynNFT loader. Okay, so here we are on our DynNFT loader computer. Note that all these files need to be in the directory. This is my settings.txt, which is a pretty standard setup, and that has to match the RPC settings that are in the full node that you're mining against. So here I'm going to start to do some of the commands. In this case, first one is create an asset class. You can see this has some metadata that says it's test asset class, and there can be up to 100 of them. The returned value that I'm highlighting there is the asset class hash. So that is the unique hash for that asset class. And that's based, again, on my owner, all of the data that's inside it, and the transaction ID. So that will be unique every time. Now I'm going to go ahead and create an asset. So in this case, you can see I've specified the asset, a class that I've just created. You can see that I have a file there called image3png, and I've created that. The data gets uploaded to the server, stored in the database, and now I've got my NFT asset hash. And then what I can do is go and send the asset class to another address. So I'm going to send it from my YZ4 address, which is my test NFT account, to the 5JY, which is the Dynamo Foundation account. And that'll transfer the address. Note that the address that you send it to does not have to be valid, so it is possible to burn asset classes or assets. If you send it to DYABCD, that will effectively burn it. Here I'm showing you how to send an asset, so it's basically the same thing. Pass the class hash, the asset hash, and then the old and new owners. And those two things give you a transaction ID, so that F9 is the transaction ID, and 80 is the transaction ID for the send. Here I'm going to do a get class. So this is the hex representation that I showed before with that asset class. It's relatively small. Then I'm going to get the asset. This asset is about 800 and something K, so it's going to take just a second to retrieve, and you'll see a whole bunch of binary data scrolling by. That is the binary representation of the asset class. That's the end of our demo.